Mars, fourth planet from the Sun, named after the Roman god of war. Its mean distance from the Sun is 228 million kilometers. Its day is 24 hours 37 minutes, and its year about 687 Earth days. It has two small moons, Phobos and Deimos. Mars's equatorial diameter is 3,396 kilometers, about half that of Earth. Its mass is about 1/10 of Earth's, and its surface gravity about 1/3 as strong. No magnetic field has been detected on Mars, suggesting, as does its low density, the absence of a substantial metallic core. Like Earth, it has seasons and an atmosphere, but its average daytime surface temperature is only 10 degrees F. Mars's thin atmosphere is mainly carbon dioxide, with some nitrogen and argon and traces of water vapor. Spacecraft images show a cratered surface with volcanoes, lava plains, flood channels, and canyons, many large by Earth standards. Olympus Mons, for example, is the largest known volcano in the solar system. Wind is an important element on Mars, sculpting features such as dunes and occasionally causing global dust storms. In the distant past, Mars appears to have had a denser, warmer atmosphere and much more water than at present. Images from the Mars Global Surveyor spacecraft suggest that some liquid water may have flowed near the planet's surface in relatively recent times. No life has been detected on the planet. Solar system, the Sun, its 8 major planets, the dwarf planets and small bodies, and interplanetary dust and gas under the Sun's gravitational control. Another component of the solar system is the solar wind. The Sun contains more than 99% of the mass of the solar system. Most of the rest is distributed among the planets, with Jupiter containing about 70%. According to the prevailing theory, the solar system originated from the solar nebula. See also asteroid, Centaur object, Ceres, comet, Earth, Ares, Jupiter, Kuiper belt, Mars, Mercury, meteorite, Neptune, Oort cloud, Pluto, Saturn, Uranus, Venus. Mars is the fourth planet from the Sun and has a distinct rusty red appearance and 2 unusual moons. The red planet is a cold, desert world within our solar system. It has a very thin atmosphere, but the dusty, lifeless, as far as we know it, planet is far from dull. Phenomenal dust storms can grow so large they engulf the entire planet. Temperatures can get so cold that carbon dioxide in the atmosphere condenses directly into snow or frost, and Marsquakes, a Mars version of an earthquake, regularly shake things up. Therefore, it is no surprise that this little red rock continues to intrigue scientists and is one of the most explored bodies in the solar system, according to NASA science. Befitting the red planet's bloody color, the Romans named it after their god of war. In truth, the Romans copied the ancient Greeks, who also named the planet after their god of war, Ares. Other civilizations also typically gave the planet names based on its color. For example, the Egyptians named it Her-Desher, meaning the red one, while ancient Chinese astronomers dubbed it the fire star. The planet's cold, thin atmosphere means liquid water likely cannot exist on the Martian surface for any appreciable length of time. Features called recurring slope linei may have spurts of briny water flowing on the surface, but this evidence is disputed. Some scientists argue the hydrogen spotted from orbit in this region may instead indicate briny salts. This means that although this desert planet is just half the diameter of Earth, it has the same amount of dry land. The red planet is home to both the highest mountain and the deepest, longest valley in the solar system. Olympus Mons is roughly 27 kilometers high, about 3 times as tall as Mount Everest, while the Valles Marineris system of valleys, named after the Mariner 9 probe that discovered it in 1971, reaches as deep as 10 kilometers and runs east-west for roughly 4,000 kilometers, about 1/5 of the distance around Mars and close to the width of Australia. Scientists think the Valles Marineris formed mostly by rifting of the crust as it got stretched. Individual canyons within the system are as much as 100 kilometers wide. The canyons merge in the central part of the Valles Marineris in a region as much as 600 kilometers wide. Large channels emerging from the ends of some canyons and layered sediments within suggest that the canyons might once have been filled with liquid water. Mars also has the largest volcanoes in the solar system, Olympus Mons being one of them. The massive volcano, which is about 600 kilometers in diameter, is wide enough to cover the state of New Mexico. Olympus Mons is a shield volcano with slopes that rise gradually like those of Hawaiian volcanoes and was created by eruptions of lava that flowed for long distances before solidifying. Mars also has many other kinds of volcanic landforms, from small, steep-sided cones to enormous plains coated in hardened lava. Some minor eruptions might still occur on the planet today. Channels, valleys, and gullies are found all over Mars and suggest that liquid water might have flowed across the planet's surface in recent times. Some channels can be 60 miles, 100 kilometers, wide and 1,200 miles, 2,000 kilometers, long. Water may still lie in cracks and pores in underground rock. A study by scientists in 2018 suggested that salty water below the Martian surface could hold a considerable amount of oxygen, which could support microbial life. However, the amount of oxygen depends on temperature and pressure. Temperature changes on Mars from time to time as the tilt of its rotation axis shifts. Many regions of Mars are flat, low-lying plains. The lowest of the northern plains are among the flattest, smoothest places in the solar system, potentially created by water that once flowed across the Martian surface. The northern hemisphere mostly lies at a lower elevation than the southern hemisphere, suggesting the crust may be thinner in the north than in the south. This difference between the north and south might be due to a very large impact shortly after the birth of Mars. The number of craters on Mars varies dramatically from place to place, depending on how old the surface is. Much of the surface of the southern hemisphere is extremely old, and so has many craters, including the planet's largest, one 400-mile wide, 2,300 kilometers. Hellas Planitia, while that of northern hemisphere is younger and so has fewer craters. Some volcanoes also have just a few craters, which suggests they erupted recently, with the resulting lava covering up any old craters. Some craters have unusual-looking deposits of debris around them resembling solidified mud flows, potentially indicating that the impactor hit underground water or ice. In 2018, the European Space Agency's Mars Express spacecraft detected what could be a slurry of water and grains underneath icy Planum Australe. Some reports describe it as a lake, but it's unclear how much regolith is inside the water. This body of water is said to be about 12.4 miles, 20 kilometers, across. Its underground location is reminiscent of similar underground lakes in Antarctica, which have been found to host microbes. Late in the year, Mars Express also spied a huge icy zone in the red planet's Korolev crater. The two moons of Mars, Phobos and Deimos, were discovered by American astronomer Asaph Hall over the course of a week in 1877. Hall had almost given up his search for a moon of Mars, but his wife, Angelina, urged him on. He discovered Deimos the next night, and Phobos 6 days after that. He named the moons after the sons of the Greek war god Ares. Phobos means fear, while Deimos means rout. Both Phobos and Deimos are apparently made of carbon-rich rock mixed with ice and are covered in dust and loose rocks. They are tiny next to Earth's moon and are irregularly shaped since they lack enough gravity to pull themselves into a more circular form. The widest Phobos gets is about 17 miles, 27 kilometers, and the widest Deimos gets is roughly 9 miles, 15 kilometers. Earth's moon is 2,159 miles, or 3,475 kilometers, wide. Both Mars moons are pockmarked with craters from meteor impacts. The surface of Phobos also possesses an intricate pattern of grooves, which may be cracks that formed after the impact created the moon's largest crater, a hole about 6 miles, 10 kilometers, wide, or nearly half the width of Phobos. The two Martian satellites always show the same face to their parent planet, just as our moon does to Earth. It remains uncertain how Phobos and Deimos were born. They may be former asteroids that were captured by Mars's gravitational pull, or they may have formed in orbit around Mars at roughly the same time the planet came into existence. Ultraviolet light reflected from Phobos provides strong evidence that the moon is a captured asteroid, according to astronomers at the University of Padova in Italy. Phobos is gradually spiraling toward Mars, drawing about 6 feet, 1.8 meters, closer to the red planet each century. Within 50 million years, Phobos will either smash into Mars or break up and form a ring of debris around the planet. Mars is 4,220 miles, 6,791 kilometers, in diameter, far smaller than Earth, which is 7,926 miles, 12,756 kilometers, wide. The red planet is about 10% as massive as our homeworld, with a gravitational pull 38% as strong. A 100-pound person here on Earth would weigh just 38 pounds on Mars, but their mass would be the same on both planets. According to NASA, the atmosphere of Mars is 95.32% carbon dioxide, 2.7% nitrogen, 1.6% argon, 0.13% oxygen, and 0.08% carbon monoxide, with minor amounts of water, nitrogen oxide, neon, hydrogen deuterium oxygen, krypton, and xenon. Mars lost its global magnetic field about 4 billion years ago, leading to the stripping of much of its atmosphere by the solar wind. But there are regions of the planet's crust today that can be at least 10 times more strongly magnetized than anything measured on Earth, which suggests those regions are remnants of an ancient global magnetic field. NASA's InSight lander has been probing the Martian interior since touching down near the planet's equator in November 2018. InSight measures and characterizes Marsquakes, and mission team members are tracking wobbles in Mars's tilt over time by precisely tracking the lander's position on the planet's surface. These data have revealed key insights about Mars's internal structure. For example, InSight team members recently estimated that the planet's core is 1,110 to 1,300 miles, 1,780 to 2,080 kilometers, wide. InSight's observations also suggest that Mars's crust is 14 to 45 miles, 24 and 72 kilometers, thick on average, with the mantle making up the rest of the planet's non-atmospheric volume. For comparison, Earth's core is about 4,400 miles, 7,100 kilometers, wide, bigger than Mars itself, and its mantle is roughly 1,800 miles, 2,900 kilometers, thick. Earth has two kinds of crust, continental and oceanic, whose average thicknesses are about 25 miles, 40 kilometers, and 5 miles, 8 kilometers, respectively. Mars is much colder than Earth, in large part due to its greater distance from the Sun. The average temperature is about minus 80 degrees Fahrenheit, minus 60 degrees Celsius, although it can vary from minus 195 F, minus 125 C, near the poles during the winter to as much as 70 F, 20 C at midday near the equator. The carbon dioxide-rich atmosphere of Mars is also about 100 times less dense than Earth's on average, but it is nevertheless thick enough to support weather, clouds, and winds. The density of the atmosphere varies seasonally, as winter forces carbon dioxide to freeze out of the Martian air. In the ancient past, the atmosphere was likely significantly thicker and able to support water flowing on the planet's surface. Over time, lighter molecules in the Martian atmosphere escaped under pressure from the solar wind, which affected the atmosphere because Mars does not have a global magnetic field. This process is being studied today by NASA's MAVEN, Mars Atmosphere and Volatile Evolution mission. NASA's Mars Reconnaissance Orbiter found the first definitive detections of carbon dioxide snow clouds, making Mars the only body in the solar system known to host such unusual winter weather. The red planet also causes water ice snow to fall from the clouds. The dust storms on Mars are the largest in the solar system, capable of blanketing the entire red planet and lasting for months. One theory as to why dust storms can grow so big on Mars is because the airborne dust particles absorb sunlight, warming the Martian atmosphere in their vicinity. Warm pockets of air then flow toward colder regions, generating winds. Strong winds lift more dust off the ground, which in turn heats the atmosphere, raising more wind and kicking up more dust.